Hello, I am Dan Anderson, electrical engineering student here at UW Platteville, and I will be going over the preliminary results of our group project in EE3210. Displayed on the screen here, we can see one of our samples in the time domain, and then what we did was we took these samples from each of us that we put in and converted that into the frequency domain in order to be able to distinguish the difference between male and female, as well as children voices in there. And so taking a look at the male voices plot, we can see the histogram here of the filtered and the unfiltered male voices. And with the filtered taking out some of the noise, we do have somewhat of a curve here, not a normal distribution, but we can see that the majority of voices are between the 50 and the 200 hertz range for males, which is somewhat expected. And if we did have a higher sample size, I think we'd be able to see a little bit more of a normal distribution with that as well. And then what we have here is the female voices. So you have a little bit of a higher standard deviation with this. But I think we can also see, especially with the filtered plot here, that the frequency is much higher for the females. Seeing the majority between 150 and around 300 for the female voices. Which is statistically distinguishable between male and female. And then we have the children voices here, which we had a few samples of as well, and which we would expect to be even higher. And then we also had that filtered and unfiltered, but you can see that that range is going from 200 to 350 or so. And so with the amount of samples that we had, we definitely had less than 40. So we were not using the standard Z table. You're using the T table for these. But I think we were able to find that there is a distinguishable difference between male, female, and children voices. And if we did have a higher sample size, we'd be able to get some more normalized curves out of that. And that's all.